Welcome back, guys. Today's video we are still in chapter 2. We are going to solve an example, a different example, and chapter 2, the deformation. We said in our last video that formula for deformation, we said is force, length over area and Young modulus. This is the formula for the deformation that we talked about in our last video. The idea of this chapter is for you to know how the member will deform, and in the last video we discussed about this, and we said that this is the force, the length, initial length, the area of the member, and the Young modulus of the member. In the last video, we also said that, for example, let me use this as an example. Let me use this as an example. For like this example, this is a member. Let's say from here, from this my hand, from this my finger now, from here, finger here to here, let's say is 10 centimeter approximately. And now let's say this my finger here is fixed, this one is fixed. Then we apply a stress here, a force here. We apply a force here. So if this is a member and it's fixed, you try to fix here, and you try to apply a force here. You will find out that this will elongate. Okay, it will add length. It will add length for like this place. If this is 10, like this now, 10 centimeter, and if you apply a force here, you will see that the member will try to elongate. This is the elongation that we are talking about in this section here. We are talking about the elongation. So this place now, what this thing is doing is what we are trying to analyze in this place. And also in our last video we said that simply in our last video you have to find this when you have this. Normally you have to find unknown with those ones you know. But today's example we are going to find unknown using some of the unknowns. So it is going to be a little bit complicated, but it will be easy. It will be easy for you to understand. Today, yes, in the last video we have shown you that this is, if it is fixed, you elongate. We are just trying to find the elongation part, which is this. So, but today we will try to solve an example when wherever you have to know where the force, you have to know how the member elongate. For like this one, a force is applied here, so you're gonna elongate here. But if a force is applied somewhere here, it's gonna be something totally different. It's gonna be something totally different from others. So here today we will apply a force in somewhere separate, not from this place like in the last video. We will try to apply a force somewhere different. So for like this one now, you know that if you apply a force, okay, let me use this. For example, this is a member, the one I'm trying to talk about here now. This is the member. If you apply a force here, you will find out that this place will come down. Let me use another. This place will come down, and this place will go up. You see? But if you apply a force here, it's just going to add length. But if you apply it here, this place will come down and this place will come up, will go up. So here, look at it now. Practically part of it. For example, if from here I am applying a force that from here, if I'm applying a force like this, as I'm applying a force, you will find out that the more you apply force here, this is not a very good example when it comes to this part. This material is not a very good sample, but I'm just trying to show you that when you're applying a force down, this place will be going up. If you're applying a force down, it will be going up, it will be going up. So we will try to find the elongation part somewhere here and this place. No more here, but somewhere here, where it elongates. So you have to know the member, the type and the kind of stress or stresses that are applied on the member. So you just have to know that if the member is applied, if a force is applied on a member, it's going to behave totally different from if a force is applied here. It will behave totally different if a force is applied here. So here today we are going to solve one example of this type. We have solved this already. We will try to solve this example today. So now we have the member. Let's draw this. We have something like this. This place is fixed. This place is fixed, and it's also fixed. Let's say call this E. Let's call this C. A, B, C. Let's call this D. This is E. Okay. Now this is a member like this. It's fixed here and it's fixed here. Okay, now let's apply a force here. You see, if a force is applied here, sometimes students find it very difficult to analyze, but it's a little bit it's quite simple though. Now a force is applied here. What are we going to do? The first thing for you to do is, for you to understand this, you have to draw the free body diagram. But before we proceed to free body diagram, you have to know what is this member. What is it? Is it aluminium? Is it brass? Is it steel? What is it? So from here, let's say that this is brass. And you said the young modulus of brass is 1.5, right? 0.5. Yes, 1.5, 105 gigapascal. Let's say the area is 240 millimeter to this. Okay, now this is the system given, and they say from here the distance from here to here is 22.5. Okay, but from here to here is 150 millimeter. Okay, now we have all this. Now let's analyze this. So as I said earlier, the first thing first, draw the free body diagram of this, so that you will be a little bit, if you want to draw the free body diagram, try to take just a member. If you want to understand, if you want to solve this so that it will be easier for you, take one. You don't need all this. You just have to show a force going down and the force going up. Take a member that the force is applied on. Take the member. It's okay by you. It will be okay. So now let's draw the free body diagram. From here we have this. From here we have this. This is our A, this is our B, and this is our C. So here we will show a force going on. Let's call it FBD. BD. And we know here a force. Let's show a force going down. Let's call it FCE. Now show the force. Let's call it P. The distance, I forgot. From here to here, the distance is 125. And from here to here, here to here, 225. Okay. Now, show the distance here. 125. And here, 225. Join the distance. Okay. Now, we already have this. We have this from here. You see, when some students, when they have a member like this, they don't know what to do. They don't know what to do. So the best thing for you to do here is just to draw the free body diagram. Do not show this, because some of them, just show them that in statics you are an expert. So some students, they will just draw this, come here and put, is it fixed? They will put 2 reaction force. Come here, put 2 reaction force. By the time you find this 2 reaction force, time is not in your side anymore. So just take the member that the force is applied on, then indicate others with another force. Now we are trying to look at this place. We are trying to find this in this member. We don't know this force. We know area. We know Young modulus, but we don't know this. So P, we don't know P. Had it been we know P, we only find this. So this is what I'm trying to tell you, that in the last video we solved this when we have everything, but here we don't have P. So we have to find unknown, or we use unknown to find unknown. That is what I'm trying to tell you, but it's not that difficult. So now we are here. What is the next step? Let's try to analyze this to find what is P. Okay, this force and this force. So now let's start. Let's take a moment. Some of them will write f of x, f of y. No, go straight to the point. When you don't know any of this, just take a moment. Okay, we say from here, moment, summation of moment at point. Let's start from B, because we are now, it seems now we are looking for P. Summation of moment at point B is equals to 0. Let's say this, let's show our direction positive. We are here. We are trying to take a moment at point B. So now what do we do? At point B, from here is negative, and from here is positive. I mean, from here is positive, and here is still positive. Because here is negative, yes, here is negative because it will try to rotate anti-clockwise to this the opposite direction of this my positive sign, and this will try to rotate it to the negative to the direction of this point, but this one will try to rotate it to the other direction of this point. So this is negative and this is positive. So let's draw it. The distance here, which is positive because it will rotate it. Look at this, look at this, look at this, and look at this. This force will try to rotate this member to the direction I call positive. So this is positive. But this will try to rotate, this member to the part I call negative. Okay? So now let's start from here. We say 120, the distance, 125 times the force, which is positive, then minus this FCE times distance 225 equals to 0. This is my moment. I've taken the moment. This we do positive. This is positive, but we don't show it. But this we do negative. Okay? Now let's make this the subject. So from here we just have to find CE equals to this, right? 1, 2. From here I'm trying to solve now for C, not for P. Solve for X force, this FCE. So now FCE here, if it goes here to be positive, so 125 over 225P. Now we have this which is our this force. Okay? Still, we don't know what is P. Okay? Right now, let's solve for. Now we know this force as this, although it's still unknown, but we call it this. Then we take moment here again to solve for FBD. Okay? Now let's take moment, summation of moment. What did I write here? So sorry. Summation of moment B. Then summation of moment at now, this time around, at point C. So summation of moment at C is equals to, you look at this place, it's equals to 0 go to positive. Okay, so the force, which is from here, the force should be P 125 plus 225 minus 225 F BD. Okay, now let me make this equals to 0. Let me make it the subject. So we have from here we have F. From here we have now our F. If we go positive, FBD is now equals to this plus this is 350, right? This 25 3, yes, 350 over 225 P. Now we know this and this. If you come here, you can show this. You can show from here, from what we found here as FCE and FBD, you can show here that this is now like this. Replace FBD with this. 350 225. So 350 over 225p. Okay, and now replace this FCE, which what we found here is 125,225p. 125 over 225p, and we still have our p. So now A, B, C. This is now our new diagram. It is now our new diagram. So now we have these two forces. Although they are still incomplete, we have to put them in our equation from here. This general equation, we have to put it there to know. We will try to know what P is tending to. So the value we found here will be multiplied by P. So now our force here is this times P. This times P, our force. Is that clear? Okay, now let's do it. From here, we know our formula is this. It's equals to force L over AE. From here is equals to, now, what is our force? We will solve it one after the other. We solve this one, then secondly we solve for this. So now let's say for member B, D. For member BD, we are solving for this from here. Now we will say that what is our force? This is our force, 350 over 225 P multiplied by length. What is our length? 2. This is our length, 225. Okay. If you are more confused here, just say we are solving for F. This is the force. So the length from here to here is from here to here, which is 225. Multiplied by 225. All over in millimeter. All over area. Now the area of the brass is given, because this is one member. Sometimes it will be worst if this is brass and this is aluminium. You have to solve it differently, but this is generally just one, so the area of both of them will be the same. So now the area of this is for this is brass, which we have 240. 2 from here is 240 millimeter to the square times Young modulus. Our Young modulus 105. 105 times 10 to the 3 Newton millimeter squared, right? Okay. So from here, you just have to solve for this, and you will find a number that is multiplied by P. So this at B, D is, you have to solve this, put a number there that is multiplied by P. So now we don't have much time. I'm trying to analyze it. So now you do the same at the second one. If you do the same at the second one, F L over A E, then this force now for this one is for Fe, for, all right, CE for this. You do the same here, and you say that the force here now for CE, the force here now is 125 over 225p. Then the distance is 150. From here to here, we have 150 distance. So that is it, and this will be the answer you will keep, just because we don't know P. So leave P like this as the answer. Likewise here. So finally, we will try to know the deformation of this member. So as I said earlier, if you have a member and you apply the force, it will go like this. Similarly, if you have a member like this and you apply a force here, this one will come down and this one will go up. The deformation here is what we are looking for. So this is the same as here, because we apply the force somewhere here. So we will have our initial here. We will have our initial member like this. Then when a force, the force here is applied, you will see that the member, this one will come down and this one will go up. So what are we trying to do? We are trying to calculate the deformation here, and this place is CE, and also this place is at point A, and this place in between is at point B, D. So if you look at this place, you see that it will deform like this because the force is applied here. So if you apply force downward, it will come down, this one will go up. But if you apply force upward, it will go up, this one will go down. So this is all about deformation, how a member will deform. You just have to have an idea of how a member will deform, the type of member, and how the force is applied on it. The way the place where a force is applied will change. It will change the deformation, the type of deformation of the member. It is not how a force is given here. It is not how it will deform when a force is given here or a force is given here. It's totally different. So deformation is a little bit quite simple. We are still in chapter 2. So it's a little bit simple if you have an idea of what deformation is all about. So thank you very much. In next video, we will try to solve more questions on this, or we will try to solve another pattern of it so we understand. Thank you very much for watching this video. See you in the next video. I hope this video will help you a lot. Thank you.